All right, let's talk about one of the most critical skills for any software engineer out there: system design. You know, the art of building those huge applications that can actually scale to millions of users without, well, completely falling apart. Let's dive in.
We've all been there, right? You get that dreaded 3 a.m. page and your heart just sinks. Something is on fire. So the real question is, how do you design systems that don't do that? How do you build something that can actually handle the chaos of the real world?
And that's the trap. On a whiteboard, everything is perfect. The lines are clean, the boxes are neat, there's no lag, no network failures. It's a fantasy. But production is messy. Today we're going to look at a tool designed to bridge that massive gap between the clean blueprint and the chaotic reality.
And that tool is called SyDe, the System Design Simulator. Honestly, the best way to think about it is like a flight simulator, but for cloud architects. It's this safe, visual sandbox where you can build, test, and even break your designs without any real-world consequences. So, at the heart of SyDe is its visual designer. Just picture a giant, infinite canvas where you can drag and drop all the different pieces you need. We're talking load balancers, databases, caches, you name it. But here's the key. You're not just drawing a static diagram here. No, you're building a live, interactive model of your entire system. And this is where it all comes to life, the live simulation engine. You can pump real-world traffic patterns into your design and just watch. You can see exactly where bottlenecks are forming, where queues are backing up, and how your response times start to suffer. All of it happening right in front of you in real time. But it gets even smarter. SyDe also has an AI co-pilot built right in that analyzes your design for you. It automatically pinpoints all those hidden risks, the potential bottlenecks, the scaling issues, and those dreaded single points of failure, so you can fix them before a single line of code ever gets written.
So how does it actually work? Well, the whole workflow is a really simple, powerful 3-step process. You design, you configure, and then you simulate.
First up, you design your system on the canvas. So let's say you're building a caching layer for a social media feed. You just drag in a load balancer, a couple of cache servers, your main database. Easy. Next, you configure the constraints. This is where you set the rules of your world, like latency targets and throughput limits. And finally, the fun part. You simulate traffic and chaos. You can throw a flood of requests at it and introduce random failures, like a cache server just going offline, to see exactly how your design holds up when things get rough.
And this just nails the whole philosophy behind the tool. It's all about proactive failure analysis. I mean, it's so much better to see a scary connection pool exhausted warning in the simulator than it is to see it in your production logs when millions of people are depending on your service.
So, where can you actually use this? Well, the applications are incredibly practical, and they really span an engineer's entire journey, from the interview all the way to production. Engineers are using SyDe for a ton of different things. For starters, you can use it to absolutely nail those tough technical interviews. You're showing the interviewer your design, not just telling them. You can also test different cloud setups to optimize your costs, maybe finding out that a different instance type could slash your bill by 20%. You can plan for massive traffic events like Black Friday. And you can even model your whole disaster recovery strategy to make sure it'll actually, work. And for interviews, being able to visualize these trade-offs is a complete game changer. Instead of just talking about the classic dilemma between latency and consistency, you can actually model it. In SyDe, you can literally turn a dial to demand more consistency and watch the direct impact it has on latency right there on the screen. It's the difference between describing a theory and actually proving it. Of course, with any tool that touches our designs, and maybe even our API keys, the first question is always going to be about security. How can you trust it?
SyDe was built with a privacy-first architecture, and the core promise is super simple. Your sensitive data, especially API keys, is never stored on their servers, period. It's a zero-trust model from the ground up.
And here's how they back that up. They use strong AES 256 encryption, but the key is generated and stored locally on your machine. Any AI requests go through a stateless proxy, which is just a fancy way of saying your info is processed and immediately forgotten. Even the optional cloud sync feature is end-to-end encrypted. Now, to make this even more powerful, SyDe isn't just a simulator, it's also a whole learning platform. It has an integrated wiki with articles, flashcards, and quizzes, so you get this amazing loop. You can read about a topic like database sharding, which is just splitting your database into smaller pieces, and then immediately jump over to the canvas to actually build it and see how it works.
So what does all this mean for the future of system design? Well, let's talk about how you can actually get started.
The barrier to entry here is incredibly low. There's a really solid free tier for all local use, which is perfect for just getting started. And the Pro plan, which unlocks unlimited AI and cloud sync, is priced so that individual developers can actually afford it, not just massive companies.
And that really brings us to our final thought. This feels like a fundamental shift away from static whiteboards and toward dynamic, simulated realities. It makes you ask a really powerful question. What kind of more resilient, more efficient systems could we all build if we could test every single decision before we ever had to write a single line of code?
You can check it out for yourself at SyDe.cc. The creators are looking for feedback. What do you think is missing in system design today?